name is Peter Capak from Caltech. I work at the Infrared Processing and Analysis Center, where I lead the effort for writing software for the Euclid project, as well as leading the photometric redshift effort for W-first cosmology, and a research group that focuses on high redshift science and the formation of structure in the universe. My main research interests are cosmology and how structure formed in the universe. So how did we go from gas that was evenly distributed after the Big Bang to the structures that we see around us today? The universe is incredibly lumpy. You see stars, you see galaxies, you see planets. It doesn't look like a smooth universe that things started. And so how did that happen is one of the fundamental questions that I want to be able to answer. In a scientific collaboration, I think the most important thing is that people enjoy working together and feel comfortable expressing their ideas in a way that will get constructively criticized. So in science, we have to look at different problems and see whether an idea works out or not, which involves picking at it and doing very detailed thinking about a problem. And that can often come across as very aggressive or unfriendly. And so the fact that people can work together and trust each other during that process of picking apart a problem and being able to construct an answer that they agree upon and then feel safe in doing so is, I think, the most important thing in putting together a scientific collaboration. I grew up in a very rural area where I didn't know a scientist until I actually went to university. And so the advice that I would give to people who were starting out in this field is that you should focus on what you enjoy doing. And if you want to be a scientist, that means that you need to be able to do physics and math and chemistry and look at the world around you and ask questions about that and then be able to solve those problems. So start taking a journal and write down questions about something that you're trying to understand, and then try to take observations of that, and then look up answers to what's going on the internet, in the library, ask people around you, and try to come to a conclusion that you can actually predict what you're seeing. So do you understand the problem, or do you understand what you're seeing to the point that you can actually figure it out from your understanding of the problem? So my favorite object on the sky is one of the Buffalo Fields, a Bell 370. That was the first object I observed on the Subaru telescope after being a graduate student. And I came back and showed the data to my fiance at the time, who's now my wife, who told me that I must have faked the image because there's no way that a real galaxy looks like that, because you can see all the lensing arcs around it.